The Akaki River runs right through Addis Ababa, and along with it, a deluge of debris that makes the water toxic. Upstream becomes progressively toxic as it winds south, meandering through Addis Ababa. Here, pollution is at its peak. The stench so overwhelming, its putrid vapors sting.
Always blue?
No, sometimes it is red, sometimes it is yellow. Different kind of paints are made from the factory to this water.
So this water is not safe for you?
Yeah.
Along parts of the Akaki, the buildup of chemicals literally makes the water bubble.
Hello, we are from GG Brown Consultants. My name is Lauren Estes, and I will be presenting with my associates Sierra Schatz, Songjun Kim, and Alex Matea about our proposed design for the Kaliti water treatment plant in Addis Ababa. Addis Ababa is the capital city of Ethiopia. With a population of about 3.6 million people, it is also its largest city. It is served by two wastewater treatment plants, Kaliti and Kotebe. This video will focus on Kaliti. Both the population of Addis Ababa and the percentage of its population whose waste makes it to the plant is increasing. We therefore propose an expansion of the Kaliti treatment plant. The current state of the effluent is very poor and isn't suitable for usage by citizens downstream. We will describe the current treatment process and the pros and cons of proposed upgrades to the plant to account for nitrogen removal, disinfection, and energy efficiency.
Over 80% of the population of Addis Ababa still uses pit latrines, fields, and forests as bathrooms, and only about 17% use flush toilets. In 2005, there was a 40 to 50% supply-demand gap in terms of water consumption, so there's still a large potential for increase in the amount of wastewater sent to the Kaliti treatment plant. So our proposed design accounts for an increase in the population of Addis Ababa from 3.6 million to approximately 5.5 million in the year 2035, as well as an increase in the quality of life and the percentage of people who use flush toilets from 17% to approximately 25%. Therefore, our design is for an increase from 7,600 cubic meters per day to a 53,000 cubic meter per day design flow.
The major sources of pollution in the city are industrial and agricultural. Industrial facilities such as tanneries, textiles, and food production centers discharge heavy metals and other toxic compounds. Agricultural pollutants include nutrients from fertilizers such as nitrogen, phosphorus, and potassium. Other major pollutants are biochemical oxygen demand, or BOD, and chemical oxygen demand, COD. Our main concerns are introducing nitrification and some form of disinfection to the current design.
The current treatment plant sends the influent wastewater directly to 4 oxidation ponds shown here. The wastewater remains in the ponds for an extended period of time to partially stabilize the water and the sludge that slowly builds up on the bottom of the ponds. This oxidation process will remove some of the BOD and COD of the wastewater and will partially disinfect the water, although the oxidation ponds alone do not sufficiently treat the wastewater to be discharged into the environment. Next, we'll discuss the many modifications that were considered for each step of the treatment process. First, we discussed the possibility of implementing a modern-day treatment plant that would consist of clarifiers, a bioreactor, and a disinfection step. This option was ruled out since the large capital cost of these structures isn't very feasible for the city of Addis Ababa. Also, the energy need for this machinery would not be very practical in the city where citywide power outages are not rare.
Digesters can be either aerobic or anaerobic and serve to stabilize the wastewater and sludge. Aerobic digesters have a large energy requirement due to the mechanical aeration of the pond to maintain oxygen levels, so we chose to use an anaerobic setup. We also determined that a covered anaerobic lagoon would be the most suitable digester for the Kaliti plant because it doesn't require additional energy to operate, and it also produces methane gas that can be collected to produce energy. There will be minimal capital costs, and it can be incorporated by converting the current stabilization ponds used in the plant. Although there are safety concerns with the production of methane, the anaerobic lagoon is still a more sensible choice due to the lack of a consistent, dependable power supply in Addis Ababa to power alternate systems.
A layer of biogas is maintained between the waste flow and the covering of the anaerobic digester lagoon. So this gas is composed of about 40% carbon dioxide and 60% methane, and it can be converted into electricity using a biogas recovery system. So the gas is pumped from the lagoon to a generator where it's combusted and then converted to electricity to either use at the plant for operations or sold to neighboring homes and industries. A heat exchanger captures the thermal waste heat from the generator and uses it for building and hot water heating at the plant.
Many treatment processes were considered. Advantages and disadvantages for each option are summarized in this table. The conventional activated sludge, or the CAS method, is widely used in the United States. However, it requires large energy consumption and complex equipment, so this process is not appropriate for our needs. The trickling filter has lower energy requirements and a simple operation, but requires expensive components. Stabilization ponds are low cost, low energy, and are simple to operate. The downside of a large land requirement is not an issue since the Kaliti plant already has a large area used for oxidation ponds.
Our proposed design consists of a series of stabilization ponds. The first is an anaerobic pond, followed by a facultative pond, and a final maturation pond, shown here. Screens and bar racks should be added to the beginning of the process to filter out any large objects. The first step in the treatment is a covered anaerobic lagoon, which will act as an anaerobic digester. This process removes suspended solids that settle to the bottom and most of the BOD. The detention time in this step, as well as the percentage of BOD removed, vary based on the temperature. The average temperature in Addis Ababa is between 15 and 25 degrees Celsius. It was determined that the detention time in the pond will be between 1 and 3 days and have a BOD removal ranging from 40 to 60%, depending on the season.
The second step is an aerobic facultative pond and will be designed to grow algae and provide nitrification. Algae increases the pH of the water, which provides disinfection. E. coli and other pathogenic bacteria are killed if the pH is at least 9.2 for 24 hours. This process eliminates the need for chemical disinfection, which is preferable since the addition of chlorine damages the quality of the effluent water. Nitrogen leaves this step as nitrate and can be denitrified into nitrogen gas and removed in the next step.
The third step is anaerobic, and denitrification occurs here. Since it's anaerobic, some algae and pathogens will also be killed. Anaerobic denitrification is chosen over aerobic denitrification because the aerobic process has higher potential to produce nitrous oxide, which is a greenhouse gas.
The G.G. Brown consultants are confident that our design will improve the effluent quality of water from the Kaliti treatment plant and also improve the downstream quality of the Akaki River to increase human and animal safety by removing nitrogen, decreasing biochemical oxygen demand, and also decreasing the level of certain agricultural and industrial pollutants. Although our proposal requires a large amount of land, it is necessary to ensure that capital costs are low and the treatment process is energy efficient and effective. It's also necessary to guarantee that our 3-pond system can function with the anticipated increase in design flow over the next 20 years. So we sincerely hope that you will consider hiring our firm to improve the treatment process at the Kaliti plant. And if you have any additional questions or feedback, this is our contact information. Please do not hesitate to reach out to us.